Hi, welcome to Analytics for All. This is lesson 12 of module 2 of our Python for Data Science course. This lesson is entitled An Interesting Problem with Pandas. I want to give you a little background on this problem. See, this came up when I was doing an article I was writing up for LinkedIn about an interesting, fraud attempt I was trying to discover in my last current profession. Before I became a full-blown data scientist, I worked as a clinical engineer, which meant I fixed things like X-ray machines, CT, anything from patient monitors, blood pressure cuffs, that kind of stuff. One of the staple jobs you have to do as a clinical engineer is at least once a year to all electrical equipment. You have to go around and perform a safety check. And in this safety check, you're supposed to write down, the measurements of any kind of leakage current you get. This is a boring, monotonous task. You can't get to a lot of the equipment. A lot of people don't like doing it. So honestly, what happens is a lot of people just write down a fake number. They just put a sticker on saying they did the job. We call that licking and sticking. So I was curious if, using some of my newfound data analytics skills, if I could perhaps, I don't know, catch somebody committing fraud doing that. So I thought that'd be neat. I thought I'd write an article about it, and I did. And so let's go ahead over to the website, and we'll talk about it there. We'll see what happens. Now, as with all my lessons, I have a full write-up on my website, analyticsforall.org. I'll have a link for that down in the description. And in this lesson in particular, you want to scroll down, and you go ahead and you can check out. Right down here, I've got a link for this fraud check. That is the data set where I'm going to be working with when I show you what I'm doing and the problem I ran into. And if you're curious at all, it all started again with this little article I wrote in LinkedIn, a little tongue in cheek. And basically, it was called Detecting Fraud in Your HTM Clinical Engineering Department, in which I was looking for somebody who was, again, saying licking and sticking, not actually doing the job, just making up numbers. Okay, so let's go ahead. We'll pop over to my Jupyter notebook and we will get started. All right, here we are. We're in my Jupyter notebook. And we always start off, lately we've been doing the PWD. I'm sure you're tired of seeing it. That stands for Present Working Directory. And it lets you know where we're sitting currently in the Jupyter notebook. Okay, so again, we could just put the full path in the file we want to open, but if we want to be lazy like I do, we can bring in the OS module here and just change the directory to where I know my file is. I dropped it in my downloads. So we're just going to change the directory, and as now you can see our new directories in the downloads. Let's go ahead, let's download our file, and it is going to be import pandas as PD. We'll use the pandas read underscore Excel to download, and let's take a look at the head of the file. And what we've got here is 3 columns. This maximum leakage current, the answer that people put, and created by. Created by is, that's a number identifying the text. So let's go ahead and we're going to come down here. So these are the different technicians. So you see the number just identifies the technician. So that's the data we're looking at. Let's go ahead and put the head back at a normal thing. And again, if you're working with data frames, this first number is actually just the index. That's, that did not come from my file. That's the index that'll come out. So let's start off. We're concerned with the answer. That's what we want to look at. That's what we're concerned that somebody is faking. We're concerned that somebody's not actually doing the work. They're just putting a fake number in there. So let's pop the answer out. If you remember pop from my working with data frames, what that does is it'll pop a column out of a data frame. So let's just rename the data frame so we don't damage the original, and we'll just pop the answer into Y. And if you want to see it, go ahead, hit Y, and there it is. And as you see, there's 998. So there's 999 total overall answers here. And what I want to do now is I want to just get the last digit. I don't want the digit behind the decimal. I want to look at the last digit because when you're dealing with fraud or these type of instances, people, when they try to make up random numbers, they're really bad at it. If you ask somebody to give you 5 random numbers between 1 and 10, nobody will give you 5, nobody will give you 0, because they just don't, in their head, they don't think those are random. They'll give you like 3 and 7. So those are the kind of things we want to look for. So we want to look at just the last digit. So how are we going to do that is I created a loop here, and just to understand how the loop works, what we're doing, we're just going to, let's just take the last number here. Let's take the first number. We had the 199.7. Okay, so what I'm going to do is I'm going to take a modulus of this. If you remember modulus, it returns the remainder, and we're going to do a modulus of a division of 10. And that's going to return 9.6999. Well, I don't want anything after that, so I'm going to wrap this as an integer. And if you remember integers when you wrap it, it doesn't round. It just literally chops off the integer. So that returns the last number without any rounding. So that's how I got 9, which is the last number before the decimal point by using this, which is what we have in here. So I have a loop. I create an empty list. I have a counter. Say while my counter is less than the length of y, I want you to append to this new A list I created. I want you to append the last digit of y. So that's what I'm doing. I'm doing modulus 10 inside an integer, and I run it. And as you can see, I just did a slice, and there we go. I got the first numbers. All right. Now I'm going to apply this to a histogram. Again, we're going to go so into this in the next module with visualizations. You'll be sick of this. But just for now, just know that if you're not using Jupyter Notebooks, you do not need this first line. This first line simply tells the Jupyter Notebook to put my graphic in the Jupyter Notebook. So if you're using anything else, you don't need this. But we're going to, from matplotlib, we're going to import pyplot as plot, and we're going to plot a hist. So we're just going to pass our A list to the histogram, and it comes out, and there you go. Now, a histogram, for those who don't know, is basically a frequency distribution. So what this says is, of all the 999 data points, about 50 of them are 0, a little under 50 are 1, a little over 50 or 2. Up here, 5 is the number 1, the highest distribution. But you notice what you're looking at here. If you took anything with statistics, you'll notice this is what we call a normal curve. It looks kind of like a normal curve, a normal distribution. And this is in nature how things come out, this normal distribution. So what we're going to do is, this is good. This is how things should always work out. I mean, not always, but naturally, this is how numbers kind of tend to round out in the world. So that is all the numbers as a whole. So I want to look at one tech in particular. I wanted to look at this 619 guy. And I said to him, okay, so I'm going to pass this through, and I'm going to filter my query here. I'm going to pass df query, and I'm going to say created by equals 619, because created by is just the column name. So I'm saying from all this, I'm pulling it normally. At this point, I say I only want the rows that are 619, and then do the same thing. I'm going to pop the answers out of them. Okay, and that worked. I mean, we can go ahead and script down here, look at. Then we can go ahead and try this. I notice I'm doing Y1, so we're doing the exact same thing, exact same formula. We're going to run this now, and we get a big error. Okay, so why do we get the error? I said to myself, this makes no sense. Why am I getting this error? So I went back and I looked at the data. Now here's the problem. So I'm running Y1, and if we scroll down, we look, notice this. 31 jumps to 62, 63. These are the indexes, okay? These are the indexes. They're telling me something. These indexes are saying, hey, this is not a list. This is a series. So if I go type here, guess what? It's a series. And I get the series because I get these pandas indexes here. And the indexes are jumping based on what they do. So it's telling me is if you go ahead, if we went up here and looked at the original file and just, you know, let's go ahead. Let's go ahead to like 65 again. And you'll see, if we scroll down, you got the 619, all of a sudden, look, 60 and 61 are not 619, so they're filtered out. They got removed in the filtering. So that's what happened, is in all this, in the filtering, it jumped. And that screwed up the count, because I'm not counting by anything funky. I'm counting by 1. So it says, goes to 31, it's cool. Then it goes to count to 32, and guess what? There's no 32. So it failed. And that's all because the series and the indexing. So one way around this is let's convert this to a list. So I just said y2 is y.1 to list. And now you'll see that if you look below, now I have type as list. Okay. Now I apply the same thing. Except now I'm using the y.2. And it comes out. And when I go ahead and do this worked, now I can plot my histogram. All right. So this was my problem. I was getting this weird failure, and this is kind of the weird problem I found. And it was all due to this indexing jump, which is resolved by converting everything to a list. Now, let's actually look at what came out, though. All right? I'm going to close out some of these so we can look back and forth a little better. Let's go ahead. Let's clear this one. Clear the error. just so we've got, and what I'm doing is hitting cell and I'm hitting current outputs clear. You could hit cell all output and clear everything. That'll clear everything. But I just want to take a closer look here. So this is everybody. This is if I look at all the text and everything they put in, this is what comes out. I get a nice normal distribution of numbers, which is what should happen. But this is when I look at 619. Does this distribution look anything like the upper one? No. He's ending it with 0 for some reason. He hasn't used 5 at all once. Not a single one of his things has ended in 5. I mean, this is all possible, of course, but this is a sign that something could look funky. And this is a well-known tool used in fraud. In fact, I got an article I wrote up called Benford's Law, which looks at the first digit, and that's used by the IRS and stuff to look at investigations. But I wanted to kind of show you this. It's kind of a cool little investigation into something. And also, it's kind of a weird problem that just stymied me. And I've got a couple articles on here that are basically on my website that truly are nothing more than, hey, man, that kind of threw me for a loop, so I wrote an article on it. So, again, if you like this video, go ahead, hit like and subscribe. Leave me a comment. Let me know anything you want me to work on. I do videos by request. Anything, it doesn't have to be Python. It can be anything within data science, SQL, R. Check out my site. You'll see I've got all kinds of things on there. Again, go to my site, check it out, like my site. Hope to see you back again, and thank you very much. This is Ben Larson with Analytics for All.